All right, you guys. So this is 6.2a, transforming and combining random variables. A lot of this is a review from chapter 2, where we learned that you are always allowed to multiply both the mean and the standard deviation, but you're only allowed to add or subtract from the mean. Never add or subtract from the standard deviation. All right. So Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. The number of passengers X on a randomly selected day has the following probability distribution. All right, so we have number of passengers and the probability of having that number of passengers. Find the shape, center, and spread. So you guys, to find the shape, you just need to make a graph with this on your x-axis and this on your y-axis. All right, so here we have our shape, which is roughly symmetric. Okay, to find the center, you want to calculate the mean, which you guys already know how to do. We do this times this, plus this times this, plus this times this, plus this times this, plus this times this. All right, and you would write that out. So notice I wrote mu of x, okay? So the mean number of passengers. So this means the mean number of passengers is 3.75. All right, and then make sure you can interpret it. So Pete expects 3.75 passengers on average after many, many Jeep tours. All right, always a long run probability. Okay, for standard deviation, again, same formula you guys already know. So you take the data point minus the mean that you got here squared times its probability plus the next data point minus the mean squared times its probability plus the next data point minus the mean squared times its probability all the way through, and then you square root the entire thing. All right, notice the notation here. You have sigma x, so it's the standard deviation of the passengers. Okay, then you need to be able to interpret that standard deviation. So on a randomly selected day, the number of people on a trip typically differs from the mean by about 1.09 people. So always remember, it's your typical distance from the mean. All right, so now for the new stuff. Pete charges $150 per passenger. We have a new random variable. So X was the number of passengers. C is the total amount of money that Pete collects on a randomly selected trip. Because the amount of money Pete collects is just 150 times the number of passengers, you can write the cost as so. All right, so they made a new table for you, you guys. And all this is here is it was 2 passengers times 150 bucks a person. And this was 3 passengers times 150 bucks a person, and 4 passengers, etc., 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 okay? So we're doing the same thing, you guys. Shape, center, and spread. What do you think is going to happen to the shape if I were to draw a new graph with cost on the bottom? Yeah, it's going to stay exactly the same. Now, my x-axis obviously will be labeled differently, but it's going to have this exact same shape, okay? Now for my center, I could go through and do mu of c, this times this, plus this times this, plus this times this. All right, do your formula again. Or you could do a way easier method. So you are allowed always to multiply the mean by a constant. All right, so it was 3.75 passengers that we got on average. And all I need to do is multiply by 150 to get my new mean. Okay, highly recommend you use this instead of recalculating the mean. Please just multiply by the constant 150, okay? And then same with the standard deviation. Are we allowed to multiply standard deviations by a constant? Yes. Okay, so my standard deviation on the previous page was 1.09. We're typically off by 1.09 people from the mean, all right? And we are going to multiply that by 150. So my new standard deviation is 163.5. What do these numbers mean? All right, what this means is on average, Pete collects this much money, right? That's how much he's going to collect from the passengers. And he's typically off by about this much money from the mean. Okay, so just a reminder that you are always allowed to multiply and divide all measures of center and location by a constant. You can multiply the mean, you can multiply the median, the quartiles, and the percentiles. You are also allowed to multiply and divide all measures of spread, range, IQR, and standard deviation, and your shape does not change, okay? Okay, for the variance, you guys, instead of multiplying by 150, you do need to probably write this down. You will multiply by the constant squared, because if I was multiplying the standard deviation, remember we can multiply our standard deviation by a constant. If you square that whole thing, you can distribute that negative, or that, sorry, you can distribute that exponent to both. So you need to multiply the variance by whatever your constant is squared. All right, now adding and subtracting. Okay, so a reminder, are we allowed to add and subtract from the mean? Hopefully you all said yes. Are we allowed to add and subtract to the standard deviation? No, never. Don't ever do it. All right, it costs Pete $100 to buy permits, gas, and a ferry pass for each half-day trip. The amount of profit V that Pete makes from the trip is the total amount of money he makes, C, that he collects from the passengers, minus the $100. All right, so we have profit is how much he collects from the passengers, minus the $100 it costs him to buy the permits, gas, and ferry pass. All right, if Pete has only 2 passengers, yeah, this is what it would look like. All right, so here's our same table. So in the previous slide, it was 2 times 150, which was $300 here, right? That's how much money he collected. But now I need to subtract the 100 it cost him to run the show, all right? And then we would do the 3 times 150 for 3 passengers, how much money he collects, minus the $100. So that's where they're getting all of these numbers here. So here's the amount of profit. And again, the probabilities stay exactly the same. All right, what happens to our shape? Yep, it stays the same. Okay, we change our x-axis, but it is the same shape. What happens to our mean? All right, now you could go through and do this times this, plus this times this, plus this times this, right? That's how you calculate means when you have a table. Or you could do it the easy way, which I highly recommend, all right? We know our first mean, okay, was 3.75. That's the average number of passengers Pete has. Then we know that it costs 150 per passenger, so this is how much money he collects. And then we need to subtract the $100. So we got 562.50, and now we're going to get 462.50 when we subtract out the cost to Pete to pay for the permit and the ferry pass. All right, so yes, we can subtract from the center. Oh, and my notation, this should say mu V, because they used V for profit. So this is how much profit Pete makes on any given day. All right, now for my standard deviation of the profit. Okay, our first standard deviation was 1.09, how many passengers we're typically off by. We are allowed to multiply by 150. Do we subtract 100? No. Do not subtract ever from the standard deviation. All right, so guess what? It stays exactly the same as what we got on the last slide, which I'm pretty sure was not that number. Hold on, let me check. 163.50. Sorry, this should still say 163.50. All right, there you go. All right, so again, just a reminder, you add and subtract from all measures of center and location, mean, median, and quartiles and percentiles. Do not add or subtract from the standard deviation or the IQR or the range, okay? And also, it does not change the shape when you subtract by a constant. Linear transformations. So now, guys, what a linear transformation is, it's just doing both in one step, multiplying and adding or subtracting, all right? So could we write a linear equation for Pete's Jeep tours using the random variable X, number of passengers, that would show the total profit? He charged $150 per person and had $100 in expenses. So let's say that V is our total profit, okay? And it would just be 150 times the number of passengers, so that's how much money he makes, minus $100. That's all they're looking for here, you guys, is what's the linear transformation. Can you write the equation for profit and number of passengers, okay? So let's try a combination of all of these. One brand of bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature X of the water follows a normal distribution. This is why we have to do this one, you guys. We have not talked about this in a while. With a mean of 34 degrees Celsius and a standard deviation of 2. Okay, so define the random variable y to be the water temperature in degrees Fahrenheit. Here's your lovely formula for converting from Celsius to Fahrenheit. All right, find the mean and standard deviation of y. So here I have the mean in degrees Celsius and the standard deviation in degrees Celsius. So if I want to find the mean of y, I just want to convert to Fahrenheit. All right, so I'm going to take this and I'm going to plug it in because it's Celsius. Okay, and am I allowed to multiply by the mean? Yes. Am I allowed to add? Yes. All right, so if you plug that in, you get 93.2 degrees Fahrenheit for the mean setting. All right, and then we need to find the new standard deviation. So you're going to write sigma y, because again, y just means I want it to be in degrees Fahrenheit. And I'm going to take my previous standard deviation and plug it in right here. Am I allowed to multiply by the standard deviation? Yes. Am I allowed to add? No. Just like don't do that part, right? You just don't do that part of the formula. Do not add or subtract to the standard deviation. So I get 3.6 degrees Fahrenheit. What does this mean? Here's my average temperature that the bathtub is supposed to be, and this is how much we're typically off by on any given day. All right, so part B is new. According to Babies R Us, the temperature of a baby's bathwater should be between 90 and 100 degrees Fahrenheit. Find the probability that the water temperature on a randomly selected day when the baby-safe setting is used meets the Babies R Us recommendation. All right, so we're going to do what's the probability that it's between 90 and 100 degrees Fahrenheit. They were super nice and told us it follows the normal distribution. So we can use normal CDF on our calculators, all right? Our lower bound would be 90. Our upper bound would be 100. And we need to use our previous answers up here because we want to all be in degrees Fahrenheit. I don't want to use the degrees Celsius. So I'm going to use the mean from degrees Fahrenheit and the standard deviation up here from degrees Fahrenheit. Okay, plug that into your calculator and you get 0.78 or 78% of the time you're in the right temperature here, all right, for the bath water. All right, you guys, I think you're good. I think you can do this. Go ahead and pause the video. I am going to go over this. Please remember that you only need to find the mean and standard deviation for the first one. After that, please use the shortcuts of multiplying by what you got previously or adding or subtracting by what you got previously. So go ahead and pause the video and then we can go over this worksheet after you guys work for 5 to 10 minutes or so. All right, you guys, so the very first one, you should have the most amount of work on, all right? So you're going to calculate your mean of x. Okay, so you're going to do this times this, plus this times this, plus this times this, etc., etc. All right, so be sure you wrote mu of x, okay, which is the number of credit hours taken, and show that work, at least do dot, 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 okay? You get 14.65. It does say to interpret, so this would be the average number of credit hours a full-time student is taking in the fall at El Dorado Community College. All right, and then I would like to see some of the work here for standard deviation. Again, we should have a sigma x representing the standard deviation of x. Okay, so we do the data point minus the mean squared times its probability plus the next data point minus the mean squared times its probability and square root the whole thing, and you should get 2.06. All right, this is how many credits we are typically off from the mean. Okay, so we have our mean of 14.65 credits and we're typically off by 2.06. All right, now full-time tuition is $50 per credit. This is cheap tuition, all right? This has gone up quite a bit. So they do a new table. Please do not redo all the work. All I need to do is take my previous mean because X is the number of credit hours and it is $50 per credit hour. And I just need to multiply. You need this notation, mu of T. So this is saying the mean now of the tuition cost. Okay, so here's my average tuition cost. You did not have to interpret this one. All right, this should say sigma T, my standard deviation. So yes, I am also allowed to multiply by the standard deviation. So here's my average cost, and here's how much we are typically off by on any given day. All right, and now we are going to add another cost. There's a $100 fee every single time. So are we allowed to add to the mean? Yes. Okay, this should actually be mu of C, all right, for the overall cost. So you add to your previous answer. Okay, 50 per credit hour plus the $100 is $832.50. Please do not add to the standard deviation. So this should say sigma C. It stays the same, you guys. You still keep your $50 per credit hour, all right, what we did previously, but do not add $100 to the standard deviation. All right, and now we're going to combine it all. So here's my average test score, my standard deviation says we're going to multiply by 4 and add to 10. So my new mean, multiply by 4, add 10 is 78.8. All right, my new standard deviation, again, do not add. Please only multiply your standard deviation to get 15.2. All right, they were super nice and told us that it was approximately normally distributed. So if I want to know what a score of at least 90 is, we can use normal CDF, lower bound 90, upper bound a big number, use this mean and this standard deviation for scores, okay? And you get about 23% for your answer. All right, you guys, your homework is right here.